you might say he's growing like a weed. And then after seeing this chart, you might say he's growing like a sunflower. What do I mean? Well, as he grows, he's a kid right here. He's getting taller as time goes on. Continues to get taller, taller, taller. And then I'm sure that once he hits his 20s, he's not really going to get taller anymore. He's just going to be the same height, pretty much. My name is Paul Pasulka, Ivy Masters Learning Center at IvyMasters.com. And today we're going to look at Test 6, Section 4, number 14, which reads, the growth rate of a sunflower from day 14 to day 35 is nearly constant. On this interval, which of the following equations best models the height h in centimeters of the sunflower t days after it begins to grow? So notice it's only talking about this interval right here from 14 to 35. And you could ask yourself, hey, do I want to look at the chart or do I want to look at my numbers here? Well, the numbers are very accurate. So you could look at your numbers. One approach that you could take, every single person could get the question correct taking this approach, is you could just pick a point on the graph. So let's say I pick 2167.76. So it's right here, but I could just pay attention to this right here, 2167.76. And what I could do is I could plug it into each equation. So if I plug into answer choice A, I'm going to pull out my high-tech calculator over here, it would be 2.1 times t. What's your t? Notice it told you that t is time in days over here. T days. Right there. Alright, so you've got your 2.1 times 21. And then you're going to subtract 15. And it gives you 29.1, not 67.76. We know that that's wrong. And now also notice it says here, it says what? Best models. So don't expect it to be perfect, but it's going to be close enough. You'll know when you've got your answer. And then we do 4.5 times 21, and then it's minus 27. And of course I'm checking answer choice B here. And I get 67.5. That looks like it's going to be our answer. And you could check all the other answers and see that they're not going to be close enough in order to be the correct answer. Now, how could you do this alternately? By the way, that plugging in a point on the graph or on the table, why is that helpful? Sometimes, and you get it here actually, sometimes students are like, oh, your slope is rise over run, and they'll count like it rises 1, 2, 3 boxes and runs 1, 2, 3 boxes, so your slope should be about 1. What's the problem there? Your intervals. Here it's easy to see. When you rise 3 boxes, you're actually rising 60 centimeters in height. When you run 3 boxes, you're actually running 21 days in time. It's easy to see here, but sometimes the boxes are just about squares, and it's hard to see that. So picking a point on the graph and plugging it in will help you to avoid making that error. Another thing that the SAT has done in the past to trick you is, notice right here you've got 0. Well, they might make this like, if they make it like 10, then it gives the appearance of the y-intercept being here, whereas if this point's really 10, then the y-intercept is actually somewhere back here where the graph would hit 0. So it'll help you to avoid those two problems. Now, alternately, what could you do here? You could, anytime you've got you've got 2 columns or 2 rows, a lot of times they are just coordinates. Notice, all these, A, B, C, D, they're linear equations. It's in the form y equals mx plus b. Instead of y, we have h. Instead of x, we have t. But they're really just coordinates. So what you could actually do is y2 minus y1 over x2 minus x1. What are your y's? They're your h. How do you know? Number 1, h is isolated in each answer choice. And number 2, you can see that h is your y-axis. So if I'm checking that out, then let's say I use these two coordinates right here for my y2 and y1, x2 and x1. In that case, what I've got is 67.76, and I'm subtracting 36.36. Enter, and you get 31.4. That's your change in y. And now what's my change in x? It's going to be 21 minus 14, which should be 7. And then if you divide the 31.4 divided by 7, you get 4.48. Notice it's so close to 4.5. So once again, you know that your answer choice is B. Now, remember there's two components to every linear equation, slope and y-intercept. So we just solve for slope. So why wouldn't we want to look at y-intercept? Well, y-intercept would be, remember we're looking from days 14 to 35. So from 14 to 35, 35 is here, and then 14 is here. And if we continued this line and made it perfectly straight, which I'm not great at, we would see that it would duck below 0. But it's really difficult to see how far below 0. As it turns out, the best model would be 27 below 0 once you hit the y-axis. But it's so hard to tell from the graph. So that's why for this one, you want to stick with finding the slope, or just picking a point and plugging it into the equation. Thank you for joining us today. If you like this video, click like. You can share it with someone who has trouble with linear equations or reading graphs or tables. So if there's any question you'd like to see answered from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.